Hello everyone, welcome to my YouTube channel. My name is Uriel Kosayev and welcome to my first video for a while and the first video in my playlist, which I will call Malware for Fun. In this playlist I will upload videos basically where I will show how I dissect malware, how I do stuff, and of course I will try to answer for questions in the community, in the comments itself, Twitter, LinkedIn, whatever. And of course, I'm not trying to show myself or something like that. I'm not trying to show that I'm the best. There will always be better analysts and researchers than me. And basically, I'm something like 10 or 11 years in this industry from a young age. And I very like it, very like what I'm doing. If today I'm actually a red team tech leader in a company named AB InBev, one of the biggest companies. I think it's the biggest beer company in the world. If I'm wrong, you can correct me, of course. And basically, I'm doing very interesting stuff, offensive stuff, in order to, make security better. And malware analysis, it's something that I very, very like. I like it very much, and I'm doing it in my daily basis for fun. And I thought to myself, why not doing video, like YouTube videos and contributing to the community. I also provide courses in this field, malware analysis, red teaming, and stuff like this. So if you want, you can go to my website malwareanalysis.co or malwareanalysis.co. And basically you can go to the page our courses and register to one of my upcoming courses. And let's get started with one of my, I think, biggest nemesis. It was a keylogger named Ardamax. So basically let's get started with the help of God. And as you can see, I'm using here Triage Sandbox or Triage whatever. Okay, so basically it's a website which which you can search and upload malware samples like VirusTotal or Antiscan.me or other services alike. And basically, as you can see, I searched here the family malware called Ardamax. So my first time with the Keylogger, I saw it in one of my clients' network, and basically it was very weird keylogger because it had traced the files and saw that it managed to drop itself in the system32 folder under some weird or random name, and basically it also had a GUI. So I'm kind of like, okay, so I didn't first know that it's a keylogger, but I started to going deeper into this malware, and it was very fast, that I understood that it's a keylogger. Basically uploaded some of the files to VirusTotal, and the detections was very, very high, like sky high. And basically I decided to research about it to better understand it. So of course, after the incident was over, the incident of the client, and me and my other colleagues cleaned their networks, basically decided to research the malware, and I actually released a blog about it. It was, I think, 1.5 or 2 years ago. I don't really remember. And basically this keylogger does some interesting stuff. Basically it logs your keystrokes, not something very, very interesting, but it can be very dangerous, of course, for your privacy and for your data. And the business model of this software, basically anyone can download it or purchase it or whatever. Today, if you're going to try to go to the website, like if I go to ardamax.com, maybe they changed the domain, I don't know, you'll receive different page, so they're not up. So basically, if you go to the blog, you can see the execution flow itself. You can see the functionality. I like going deeply into malware to understand their inner mechanisms the type of functions or the functionality they have, and not just, you know, statically or dynamically analyze them, you know, drop them to a sandbox like Anyrun or one of the other great sandbox out there. I'm trying to really understand their essence and their goal. So for example, you can see here it creates a folder named 28463 under the system directory. If it's 32-bit system, it will drop it to the CISO64 folder under the C Windows path. And if it's the 64-bit version, which are the most versions of the operating system out there today, it will be basically the System32 folder. Yeah, I know it's like the opposite. CISO64, it's like System Windows on Windows 64. It's like a compatibility folder of all of the 32-bit executable versions. Like for example, you have calculator.exe. So why am I talking about this? Like, you know, let's go to say Windows. So basically, if I go to CISO64 and for example take calc.exe and put it to software like CFF Explorer or PStudio or one of those great free tools available out there, you can see it will be 32 bits. So if I go to System32 and search for calc.exe, it will be 64 bits. So a lot of people sometimes you know, miss this or don't know this basically. So just to mention it, and it's fine. Of course, it's not like I know everything in this industry. People who say they know everything, you should be very careful and, you know, don't be around them. You need to be more with people that care about each other and more you know, alongside people that they say they don't know everything, but they will to give you their knowledge basically and their experience. So this example of this blog basically, and one of the files called dpbj.exe, and basically I want to kind of see if today's Ardamax keylogger is the same. And you can ask a question, okay, but the website of Ardamax is not available, so why the hell you're going, you know, doing a video about it? Yeah, because basically if I go and search Ardamax, specifically in the Triage website, I have the family tag and I can search for specific malware. For example, I can search for Emotet, one of the like most distributed malware today, and doing a lot of damage, a lot of bad, and it's very interesting to learn from such malware in order to detect them. And of course, as an adversarial mind, for me as a red teamer, also to learn from them. Yeah, learn from the bad guys and try to like learn from their techniques, not only for detecting them, but also to use those techniques in order to test your networks as white hat hackers or white hat security researchers, defenders, or whatever. Okay. So I'm going back to Ardamax, and as you can see, the latest, like the last sample that were uploaded was in the 11th of March. So it like yesterday, yeah, today we're in the 12th of March. So very interesting. So the website is down, but we have a sample uploaded and has a score of 10 out of 10. In the base of this malware, it doesn't really try to be evasive and try to like evade antivirus or EDR or some other endpoint protection systems. Basically, it's very interesting to also check this against virustotal.com. So let's do search. Yeah, no shit. 49 out of 67. We can see here some detections. Those are the actual names, or the name of the signature, or the detection of the malware, whether it's static detection or dynamic detection. Basically, the difference between static and dynamic detection. Static detection of antivirus is like detecting malicious patterns of files, basically, before they're executing. And dynamic engine or dynamic detections basically detect malicious patterns on executed executables, which are called process. Okay, and process basically is an executable, like a game or software that you execute on your computer. Of course, I'm explaining for those who don't know, and for those who know, great for you. So we don't really see anything regarding Ardamax for this specific hash, so maybe it's a different malware. Okay, so here we can see it communicates to an smtp.gmail.com, so basically to an SMTP email. And it's not very odd for Ardamax from my experience, because if you go to my blog also, you can see that it tries to communicate. Let me just zoom in. Yeah, where it is. I hate when it when it happens. So it tries to basically communicate to an SMTP email. Okay, so I can just to open this image. Yeah, much better. Great. So let me just go back. Yeah, great. So as you can see, it goes to a specific email and tries to authenticate in some way. But of course, in this case, because this email is not available, in the case of the blog, of course, it receives a quit message. Okay. So, and as you can see, mailbox unavailable message before the quit message. So basically, it's not so odd for this keylogger to communicate to the email. And why the hell it will do it? Basically, it's an exfiltration method. So it takes and logs your keystrokes, it takes screenshots, and basically packs them to a zip file most of the time, I think, and then sends it over an email address, some specific email address that most of the time will be of an attacker. Of course, smart attackers will not use their regular email or their personal ones. They maybe create some Gmail or some Proton email or whatever method they use. So as we can see here, we have some tags, collection, keylogger, persistence. It uses some persistence mechanisms. It's a stealer, of course, because it steals information from your computer, and a Trojan because maybe it tries to like mask itself as a legitimate software. And as we can see, VirusTotal, we see Adobe Download Manager. So kind of interesting. Let's see what the community has to say about it. So nothing special, I think. So let's leave it as is. So we can see that it uses an SFX. SFX, basically, it's a RAR file which is self-executed. So interesting. I don't really, believe right away for stuff that appears in VirusTotal. I want to validate them in my local machine, and then in order to be, sure about it. So you can see some of the sections of the file, the header. So from the header, we can understand that it's 64-bit executable. The timestamp, the compilation timestamp. So it was compiled like in 2013. Of course, it can be changed, basically, malformed, and we can see that it has 6 sections. The text section, which holds most of the time, of course, it will be called text, but of course, an attacker can change the section. The text section basically it's the code, it's the actual code of the file. So it's like, for example, you have a C program that you wrote, or whatever language that you used, and when you compiled it, the compiler took this C code and transformed it to a machine code, to assembly. And I'm explaining this because most of malware that you research, if it's an executable dynamic link library like DLL, or an SO shared object in Linux operating systems, basically they will be machine code. Okay, of course you have other types of malware like macros for Word and Excel and PDF with JavaScript, and and it goes on and on with VBS script and VBScript and like I said, macros. It's called VBA macro and XLM macro. You have all bunch of codes that can be executed in some way on your machine. So we can see imports and other interesting stuff that we will go into more details when we jump into our machine. So you can see also the type of relations to which files or IP addresses or domains or emails or whatever it tries to communicate. And we can see from the results of VirusTotal that VirusTotal actually did not detect the dynamic execution of the file. So when I said dynamic execution, I mean to the fact that VirusTotal does not show here in this specific report which IP address or email or external entities it tried to communicate with. So in hatching triage, you can see that it actually detected the dynamic execution, or the execution basically of this malware, and also managed to intercept the communication itself, or the exfiltration of the data. So enough talking, let's go and download this sample. You can register freely to Triage. I'm not they're not sponsoring me or something like that. I'm just like 2 days ago noticed their website, and also added to the Malware Analysis Co. website. When you go to resources and you go to sandboxes, you can see Triage, hybrid analysis, other great systems that can emulate and do sandbox analysis, which is basically an automated malware analysis, which is fine, but for some cases it will not detect the malware, or not even understand and intercept its activity, because some malware can evade such sandboxes and can detect such sandboxes. Okay, so as you can see, maybe in the case of VirusTotal, it didn't really emulate this file for some reason. Okay, so let's go to the downloaded file and copy it to my Windows 7 malware analysis machine. I'm using Windows 7 because I like, while I'm doing my malware analysis, sometimes I like to do memory forensics. Basically, I'm dumping the memory of the machine, and then use volatility in order to analyze the memory dump of this machine. And Windows 7 actually, it's much more easier for me to use Windows 7 because it's faster. It doesn't have all the garbage that Windows 10 has, and also it's much more easier and faster to use with volatility. And basically that's it. This is for me. So here we have the zip file inside the virtual machine. So let me just unpack the file. And I have another fact. Windows 7 doesn't have Windows Defender pre-installed on it like in Windows 10. And in Windows 10, it's sometimes very frustrating to drop a malware, and then Windows Defender goes like, oh, nuts, and catches the malware and deletes it. And I'm like, no, man, give me a break. I want to research. I want to analyze this malware. So go the hell up. do your dirty job, or excuse me, your great work, and step aside for now, and that's it. So the password for zip files, when you download from such websites like AnyRun or Triage or VirusTotal, it will be infected. So basically, let's change the name first of all. So I call it Ardamax. So for now, I'll do .x and I will not call it .exe, so it will not be executed accidentally. So let me start with a good old-fashioned strings on it. So let's go CMD, go to the desktop, and execute strings. So strings is part of the sysinternals tool or suite of Microsoft. You can write Google sysinternals, and it has a bunch of software like strings, Procmon for process monitoring, process explorer, and other interesting stuff that we'll explore by time while researching malware in this channel. And of course, you can also go to other great YouTube channels in that available out there. So let's do strings Ardamax and output our strings called output.txt. And as you can see, we have uploaded the text of the file. I use here, if I remember right, I have Visual Studio Code maybe. Yeah, great. So let me just open this strings file in Visual Studio Code, which is a great text editor, by the way. I recommend you using it. Inside a virtual machine, it can sometimes be terrible, I know. So let's search for specific strings, or see interesting strings out there. So see a bunch of gibberish here, and this is the end of the executable strings basically, and it's basically this is part of basically all executables out there, and this is the part which tells you which privilege it requires, like whether it requires an administrative privilege, and then will have this UAC window pop up, and then you need to do like yes or no, and other interesting information that can be used. But for now, we're going to see other stuff. So we can see that it used the Adobe system, strings, some Adobe stuff. So it may seem legit, but I don't really think so. Let's see other interesting stuff. We have here 1.exe, install.exe, which can be interesting. Really recommend to note interesting stuff aside. So like 1.exe and install.exe can be very interesting. So maybe it will be used as an IOC or indicator of compromise. Basically, an indicator of compromise can be file names, folder names, can be hashes, can be IP addresses, any indicator that can indicate of an attack happening in your network. Okay, and you can use it in order to create firewall rules or HIPS rules, HIPS, antivirus signature, and any of the other security interesting stuff. So let's see if we have other strings we can see here. So it seems, yeah, we have something maybe. Yeah. So it's much more easier to use this Visual Studio Code. It's kind of slow because I'm using it inside my virtual machine, I know, but generally it's great. So I can see here some interesting stuff like command, like for example, the shell 32DLL and lookup privilege value, which can be used to look up privileges, basically token privilege, like for users, or maybe this malware searches for administrator or something like this. Recreate key, which is another what's so-called Windows API function. And Windows API function is basically a functionality which Microsoft provides in order for software programs to interact with the operating system kernel. Basically, developers or malware authors or legitimate and non-legitimate users can use those Windows API functions in order to interact with the deep mechanisms of the operating system. So the operating system basically has a kernel and a user space. So it's called user space and kernel space. So user space, basically the GUI that you're seeing, the command line, everything that you're using. And the kernel space basically is the core of the operating system. If it's Windows, Mac OS, or Linux, whatever, it has a kernel. Android, iOS, any operating system has a kernel. Even the antivirus, any type of antivirus or EDR, has what's so-called a core kernel, the same. Okay. So I see here something that's called extract cleanup. It can be legit from one side, like cleanup, like cleaning up dropped files in order to free some space for you, or it can be a cleanup in a sense of offensive cleanup or anti-forensics approach. So when I'm attacking someone or something, I want to clean my traces, for example. So let's see what else. So it's basically the strings program parsed what's called the IAT, the import address table, which is a table which contains all of the Windows API functions which will be used by the program. Okay, so basically the strings just cut them up and printed out here. So we can see here load library, which loads DLL files, get system info, gets the system's info. If, for example, I don't understand or I forgot about what is the meaning of this Win API function, of course, my best friend is, you name it, Google. So get system info, MSDN. MSDN is the official documentation website of Microsoft. So basically, it is used to retrieve accurate information for an application running on top of Windows on Windows 64. So yeah, Microsoft documentation is not always descriptive, but basically it gets info, whether it's 32-bit or 64-bit or whatever. Maybe I'm not, explaining something here precisely, but you can always research and go into more information. Maybe other websites have other great explanations. So determine whether the OS or POS is 64-bit. Okay, so it's like if it's 64 or 32-bit, basically it's 1 or 0, true or false. Yeah, so basically that's the meaning of it. And we can go into the structures of this function, basically. What is the process architecture? What is the offset address, minimum or maximum, I presume, and other interesting information, which you can go again to Microsoft documentation and understand each one of those fields, what are their meaning and stuff like this. But again, we don't need always to go so deeply into the internals of stuff. So let me get back to the machine. So I'm seeing here sleep, create thread, get temp path. So yeah, I'm saying that basically it's Ardamax Keylogger. Most of the time it will use, like most of the Ardamax or maybe all of them, get the get temp path with API function, and it's because basically it's part of the loading or loader mechanisms that the malware uses. It gets the temp path, the basically the path of, if I do percentage and go write temp, it will go to this temp folder. It will drop some DLL files and load them again, like a self-loading or self-injection, or call whatever you want mechanism, okay? And it executes their code. So it drops a DLL file, like it unpacks or drops a DLL file from itself to the temp folder and loads it back with the load library function. Why it's doing it? I can maybe think of maybe because it was a good evasion technique from antivirus, maybe to make analysis of this malware harder, or maybe other reasons. I don't know. It's just interesting, and I don't always go into understanding the mind behind this. I very like doing it, but not always, because sometimes you just don't know. So you get to the flow. And you have other stuff. Let me search for the set Windows hook. Don't see. Okay, so what I try to search is for a function named set Windows hook X, and the reason is this. If I go to research publications, and again, it's a malware that I researched while like 1.5 or 2 years ago. So the keylogging mechanism itself was based on the set Windows hook X Windows API function, and basically it can be used in order to hook mechanisms in the system, like the mouse or the keyboard. How the hell I know it? So basically I can see here the assembly instruction push 2, which pushes the value of 2 to the stack. Stack is one of the types of memory. We have stack, we have heap. Basically stack is working based on what's so-called LIFO, last in, first out. So the last value that goes into the stack is the first one. The last value that goes into stack is the first one to go out. So, and basically then it calls using the call instruction, assembly instruction, and calls the set Windows hook X. So if I go and search set Windows hook X MSDN and read about this function, you can see this function is set Windows hook X, and as you can see, one of the parameters of this function is called ID hook with an integer type. Okay, so ID hook is the same parameter as you can see here, ID hook. So basically here I'm using the program called IDA Pro, which is a disassembler. It takes a machine code or an executable, disassembles its code, and basically it translates the hexadecimal machine code values into readable, human readable assembly code. It's very hard to say about assembly that is a human readable, but when you get the hang of it, it's much easier. So basically functions using the stack, and the things that they're using in the stack are the parameters of the functions. So basically, whenever the function is called, it uses the parameters which were pushed before it into the stack. So you can see here push EAX, then this parameter, and then the last parameter, which is ID hook, which is 2. And then it's called the set Windows hook X, which is basically the function itself. And basically that's it. So I try to kind of understand if this version of Ardamax that were uploaded like one day before, wherever it is, basically if it uses it. So from what I'm seeing, I'm not very sure. So let's go into the machine again. I'll close it. Choose the strings, and let me just go and open it on another great tool, which is called PEBear. PEBear is written by a great researcher, which is called Hasher Z. This is actually her nickname in Twitter. And basically, this is a great tool which can show you the inner of this file. So basically, it takes a P file format, portable executable, which can be executable file, dynamic link libraries like DLL. It can be a sys extension file, like it's for drivers, which also uses, of course, the portable executable. SCR file for screensaver. Yeah, screensaver also uses the PE format, and a lot of other file types. So I can go here and see important information regarding the file. For example, we have here the 4D5A. I'm reading it in the opposite order because it uses basically Windows Intel based machine, or what's called little endian. Little endian is basically the way that CPU reads the bytes. So it reads from basically from the least significant bit, okay, which is basically the right one, and the most significant bit, like other CPU types, which is called big endian, it's called from the left side of the bits. Maybe I'll go into more details about it in next videos, but basically, if I open the file in a hex editor like HXD, you can see that the value in ASCII is MZ, and in hexadecimal is 4D5A basically. So this is the header of the file. You can see the MZ. This program cannot be cannot be run in DOS mode. It can be also changed, of course, and basically it's one of the headers that indicate that is a file of a basically it's a PE or portable executable file. So you have here the data, pdata, idata, resource section. So all the sections are like part of the book, okay, and basically it indicates places in the book itself. So the text section indicates the place of the code. So if I go down, for example here, this is part of the code, okay, the text section, for example. So if I go here to the imports, I can see the DLLs or the functions which are imported from the DLL files. So I can see some interesting Windows API functions like get token information for the token privilege of the currently executed or currently used user, and it checks whether it's an administrative user or not. It opens some registry values. It tries to adjust token privilege. Maybe it tries to escalate privilege in some way. We need to validate it. So if we go to kernel 32 DLL, we can have other functions like write file, which basically does exactly what it says. It writes to a file. After, of course, you get a handle to a file with functions like create file. Okay, so yeah, basically you have the sleep, other interesting functions, query performance counter that may be used, or get count may be used for anti-debugging purposes. Whenever I try to debug malware, maybe it will try to break the debugging, and of course it's very easy to bypass those while you're debugging with IDA Pro or X32DBG or whatever. So if we go to user 32, let's see. So Set message, get message window, try to understand where is the keylogging mechanism here. Set Windows text. Maybe it's on different on a different stage of this malware. Okay, because this malware basically drops other stages of this malware, so it is somehow different from the malware that I've researched like 1.5 or 2 years ago. So very interesting. We have here cabinet DLL, whatever it is. Maybe it's interesting, maybe not. It's not. GDIs for GUI stuff. Get device caps. I don't really remember this API function, so let me just go and Google about it. The device cap function retrieves device specific information for the specific device. Yeah, whatever. Thanks, Microsoft. Help me a lot. Okay, maybe try to. Nah, it's stuff with colors. Let me try. I don't really think. Let's search for keyboard. Yeah, nothing. Hate this voice whenever it. Okay, so let's go deeper with this malware, shall we? So let's open it up with IDA Pro. So from what we saw, it's 32 or 64 bit. So CFF Explorer, 64-bit. And you know what? Let's do another quick tour with P Studio. Another great tool by Mark. Mark is, I think, one of the best researchers in this industry. Does a great job with P Studio, great contribution for the community. So Mark, yeah, this is the guy. Okay, this is the guy, P Studio. So give him a round of applause, doing great job. And of course, he has also a pro version of the software, but the community version is also great. So automatically it uploads to VirusTotal, does some stuff. See the Trojan, yeah, whatever. Already saw it thinks it's adware. I don't know why, but okay, whatever. Maybe it also does some adware stuff. Didn't really know. Didn't really see something regarding it. So we have directory, resources. We have some resources. Interesting stuff. What do we have here? Okay, maybe. Okay, so basically the resources tab here shows the resource or .rsrc section that we already saw like when we used HXD. So here, okay, so rsrc or resource, basically it's one of the, like, it's another section in a P file that can be used in order to store interesting data. It can store, for example, GUI stuff like icons, the cursor itself, how it will be looked whenever you're using the software, you know, generic stuff. But it can also have, the resource section also can have stuff like another executable file or a shell code or a DLL file or other malicious stuff. So let's see if we have maybe the MZ header or something like this. So let's see PNG, MSC, if stuff like this. We have something with command here. So install exam. So maybe it's just a string or whatever. So we have this. So basically those IOCs or strings is the one that we saw already in the strings that we extracted using the strings program. And yeah, so it'll be much more easier, I think, to open it up in Resource Hacker. Specifically for resources. So as you can see, it literally has some GUI Okay, maybe it is kind of a Trojan with an interesting icon, tries to suck you up into malicious execution. Interesting. What do we see here? So we see here something that's called MSCF, called cabinet. So I think it's the installer itself, maybe. So let's copy those bytes and do some Google, because I don't remember everything. I'm not a prophet or something. So yeah, let's see if it will not. So let's go list of signature file, Wikipedia, Microsoft cabinet file, cap file. So yeah, so yeah, it's another file type which we can also check. So cabinet file is an archive file format, blah blah blah, the compression, doing interesting stuff. So it's kind of an archive, yeah. So it's also in antivirus signatures, stuff like this, you know. Interesting. So we can see maybe which malware use it or stuff like this, you know. But whatever. So it has some cab inside it with installer tags there and other stuff. So basically, oh, okay. So I think it actually unpacks the next stages from this file. I don't sure, because again, it's not that I've researched this malware before I made this video. I just jumped to it. This is why I call this playlist malware for fun. Okay, so it's not like I'm researching this specific malware before or whatever. In this case, I researched another variant of this malware, but as you can see, it's kind of different. It doesn't have the set Windows hook X function used, and interesting. So use Adobe Download Manager, whatever. Okay, if we see manifest file is part of the executable file itself. So request privilege as invoker. As invoker basically says that whatever the user privilege level is, whether it's regular or if you have the run as administrator, so it will execute as the user executes it. Okay. If it were the value of ask admin or whatever the value was, it were literally pop up a window, UAC window with the yes or no. Okay, so this is basically what it says. And Express extraction tool, whatever it is. So so the Express extraction tool basically, yeah, can be also used for detection, signature, whatever. Maybe it's a legit tool, maybe not, I don't really know. Yeah, so this for the resource file. So we can also try to extract it, save bin resource into the desktop, and let's call it for now, yeah, we can call it .cab, .bin, whatever we want, but it's basically, most of the time I will save it as .bin, and then I put it into a normal hex editor, and now I can see MCF, can do this button here, which gives him more visibility into the data. Let's say we have interesting strings here. Of course, we will not see something interesting because it's like archived, and most of the archives like doing a gibberish stuff to the data. So use some encoding or not encoding basically, and compression algorithm like zip or zlib or rar or whatever it is. So let's see if we can change it to .cab. Yeah, sometimes it has some problems. So let me check it right away. Okay, managed to extract it, so everything's fine. Could do like save bin resource, renamed it to cabinet1.cab right away. So basically I can try and open up this file. I can see two files inside it. So we see the one exe, install exe, whatever. So let me just extract them out and see. Okay, you know, let's start by doing some VirusTotal. Okay, so let's upload to P Studio. So let's put it inside P Studio. Let's open it up again. Install exe. Okay, of course malicious, so why not? And let's see if we can Studio, yeah, one name. Let's see, put the second one. So we have here the cab. So both of them are malicious for sure. Both of them executable, 32-bit. And let's check the sections, whether they're packed or not. So we don't see any high value entropy. Most time, if the value entropy is more than 7, it's one of the indicators that it's packed. One of them. We'll talk more about this in next videos. So yeah, Trojan Keylogger, password stealer. Now you see more of Ardamax. Hey. Okay, so here we go. We have Ardamax. It's like we have the Ardamax signature name, the actual signature name for this by Trend Micro. So Icarus or other stuff. Let's go to VirusTotal, and we can see here dropper. Stealer, malware gen, malicious cycle. Okay, so basically, so maybe it's the dropper. So this is the next stage, like basically it extracts the cabinet file, executes the one, then it executes the install, or the other way around, or whatever. We need to validate it. So yeah, pretty much interesting. So okay, so let's go and do a tiny analysis of the first stage in IDA Pro, and then we do a second part. So let's go to our IDA Pro. So this is Ardamax exe. So those are the second stages. This is the strings. We can delete it. We don't really need it anymore. And yeah, so again, it was 64-bit, I think, before I'm choosing the right IDA Pro version. We have 32-bit and with the 64-bit. So let's drop it to IDA Pro, Ardamax X. Do load resources also. So it loads the resource section data itself. I don't have the PDP file for this. PDP file is basically debugging or symbol file with the name of the functions and other interesting stuff, which can be used for analyzing the file and for debugging purposes, etc. So if we go to imports, we can see the used, basically the used functions here. We can start by going to some interesting function like get account, for example, and see, okay, so it's part of the iData. iData basically is the section which holds the IAT, import address table, which basically has the addresses that points to the actual function or Windows API function itself. So if we do X, it will cross-reference and we can go to the function itself. So basically it uses it a number of times. I don't really know if it's for debugging, like for anti-debugging purpose. So can maybe put a breakpoint in the start of the subroutine of this function, see whether it's used or not. Okay. Let's see who's calling this function, the start. Maybe it's the start function. Yeah, so right away it uses it. So we have the, so if we do Control E, we see only one entry point. It's a, whenever you start with analyzing malware inside IDA Pro or whatever, always seek for the entry points that you have. In IDA specifically, it's Control E, because sometimes you have what's it called, a callback functions, a TLS callback function, which is basically a functions which are executed before the main or the start of the program. So you have the start of the program or the main or the where the code supposed to start, and then you have the TLS callbacks, which are the like a pre-functions. Like you have a book and you have the preface section. That's it basically, and you can check them up here if they are not hidden in some mumbo jumbo trick that the adversaries or the bad guys used. So we see that the function is called here, and there is a get count, query performance counter, whatever. So without really going deep into the assembly mumbo jumbo stuff, we can see only by the functions itself that it uses the function, but it doesn't really tell whether it's an anti-debug technique used here. So we can basically put a breakpoint outside here and basically debug it, start, and see whether it stops the execution. Before we do that, I want to go really deep into the code and start to analyze and all of that, but let's do a second part. But before that, let's try to execute it. So I put a breakpoint with the F2 key, and then I need to, you know, choose the right debugger. We have different type of debuggers. I'll use the local Windows debugger in this case. So start, yes, whatever. Okay, so the execution of IDA or the debugging here stopped. So if I do F7, it will go inside the subroutine or the function itself. Okay, most time I like to close those windows. Also this window, maybe the threads I can, yeah, also like to close it. But the threads window is good for malware that are multi-threaded, which by the way are pretty much harder to analyze than a single threaded malware, but whatever. So if we go and execute through this malicious code with the F8, again, the difference between F7 goes into a subroutine, F8 executes the subroutine without going inside the code. So here we can do F8 without too much care about the assembly code here. So it gets the current process ID, the PID in hexadecimal, you can see it E2C, which will be translated to whatever it is. Don't really a translator in my, so I can, in my head, so I can copy this value and go to CyberChef. If you want, you can use Python in order to do it, but I love CyberChef. Okay, so hex to that's nah. Okay, so it's from hex maybe. I don't really remember. So from hex E2C, not this. Okay, so to decimal, 2 decimal. So it's like, hell with it. So CyberChef good for other stuff. So I like to do hex to that's good old fashioned calculator. Hexadecimal to decimal converter. Enter hex value, convert. So this is the PID 3628. So if we go back to the machine, 3628, go to Process Explorer or Process Hacker, also great program, and seek for the 3628 PID. Let's do it like this, or As you can see, 3628. So that's it. Okay, so let's get with it. Thread ID takes the thread ID, does the get T count, which is okay, so it do shift lift, source, some stuff, get T count again, goes on and on and on and on. Query performance counter, the value returned is 1. Let's see, it moves it to, okay, so move something here. So whatever it does a return. And basically don't really see, okay, maybe it will exit somehow. No. So don't really think. Okay, so basically I don't really think it's a anti-debugging mechanism here. So let's stop it and put a breakpoint on the start of this program. Let me check something else. If I go to the jump immediately, jump to IP, instruction pointer, no, set instruction pointer, F7 in order to enter to the function subroutine. And basically I want to see whether it takes a different way. So like it goes to the same piece of code. Yeah, it goes to the same piece of code, doesn't really seem to care. Okay, so basically let's stop this analysis for now because this video is too long, I think, and I'll do a part 2 for this video, and which will analyze further this malware and do great stuff. So basically, thank you very much for watching this video. If you basically like this video or you have some suggestions or whatever, you can comment, and please do this YouTube stuff with a like and subscribe, the bell button, all of this stuff. And that's it pretty much. Thank you very much, guys. Have a great day. Have a great week ahead. Goodbye.